This is Consett Iron Company's new 132-inch 4-high plate mill at Hownsgill, County Durham. Designed to produce 10,000 tons of steel plate each week, it is one of the most modern mills in the world. In May 1958, at the commencement of the earthworks operations, Hownsgill looked like this. The new site of 70 acres was chosen to avoid interference with production of the existing mill, and because of its proximity to the main works. The site is approaching 3/4 of a mile long, and was originally used for coke stocking and for agricultural purposes. To the southeast is a large spoil heap, part of which had to be removed. For safety reasons, the old tipping gear was first demolished. Although this part of the heap had been disused for over 40 years, it was still burning. As the excavator took each fresh bite, clouds of dust and fumes were released, which made the early days of site clearance rather hazardous. Over much of the site, sedimentary rock had to be loosened by blasting. During the course of excavation for the foundations of the mill and mill building, over 250,000 cubic yards of rock was removed. The land sloped from north to south, and almost 2 million cubic yards of earth had to be moved to level the site. Although much of the tipped elsewhere, some was used to raise the lower south end. The first months of 1959 changed the now fairly level quagmire into a frozen waste. In spite of snow, work on digging the foundation was well underway. Throughout the digging, old colliery workings presented a complication which meant increasing the depth of all foundations. In March 1959, after 10 months of work, the site looked like this. These are the 5 excavations for the 52-foot deep mill stand foundations. Bearing in mind the heavy duties which they would have to perform during the construction of the mill and afterwards, access roads were prepared early in the program. Foundation holes for columns to carry the structural steelwork were excavated and prepared for the reinforced blocks. And this is the first of a total of 145 main columns erected on the afternoon of 4th of May 19... Erection of main columns and crane rails was programmed so that the main part of the mill could be served by overhead cranes as early as possible. During the following weeks, crane girders like this one, 100 feet long, 12 foot 6 inches wide, and weighing nearly 60 tons, together with more columns and roof sections, became commonplace sights in the neighborhood of Consett, and it was not long before the mill building took on recognizable shape. Special trailers had to be constructed to transport extra long sections, such as this crane flight, from Consett Company's shops to the site. By mid-1959, work was proceeding and in the motor room. To meet the demand for concrete, a special batching plant was installed. Concrete was distributed either by wagon or pipeline. 100,000 cubic yards of concrete and 2,500 tons of reinforcing bars were used throughout the project. At this stage, about 1/3 of the framework had been erected. Because of the special roof design, site assembly of the slender roof truss sections was necessary. The program involved the erection of 12,000 tons of structural steelwork, much of it at a height of over 70 feet above the ground. A coat of protective paint on the completed steelwork, and it was ready to receive the cladding. For the walls of the main building, 20-gauge galvanized steel sheet was used. In spite of delays due to heavy rain, the main building was making satisfactory progress. During typical December weather, construction proceeded on 2 specially designed bridges to carry the existing British Railways line over the access lines to the new mill. The largest plates ever rolled at Consett were used to construct these girders, weighing 10.5 tons each and spanning over 63 feet. Eight miles of rail track was laid by Consett Company's traffic department. This represented both straight track and the complex sidings for handling incoming slabs and outgoing plates. The main body of the mill building was February 1960, and work was commencing on installation of the equipment. The first giant mill drive armature, weighing 50 tons, arrived from Stafford for installation in the nearly completed motor room. Special traffic arrangements were needed when transporting the 2 mill housings from Sheffield. They weighed 160 tons each and were among the largest steel castings ever made in this country. Of all the plant installed by overhead crane throughout the mill, this was the heaviest lift. Altogether, 20 overhead cranes will be provided throughout the mill to lift from 7.5 to 150 tons. Moving into position to form the main frame of the mill stand, these huge castings must be set to precise limits, for this is the center of the mill, where high-quality steel plates will soon be rolled to meet the demands of world industry. Meanwhile, work proceeded on the installation of the roller tables, which are used to carry rolled plates to other parts of the mill. At the north end, more concrete foundations were being prepared well in advance, ready for the transfer banks and shears, whilst at the opposite end, in June 1960, this was the first of two 3-zone slab reheating furnaces. High-duty refractories were used, manufactured at Consett Iron Company's Jarrow Brickworks. Nearby, the completed shot glass foundations were ready to receive the equipment. By mid-August 1960, the mill stand was almost ready to receive the rolls. Satisfactory progress was made on the installation of the approach table and pulpit. Further down the mill, the cooling tables, turnover gear, and one of the shears were nearing completion. Outside again, and the remaining cladding sheets were fixed on the north end of the building. By now, the water treatment area stands complete and silent, with its settling ponds, pumping station and tower. Soon it will be cooling 500,000 gallons of water per hour for the furnaces. The rail tracks await their first trainload of slabs from the main works. The oil sidings are ready for the rail tanker trains, from which oil will be pumped to the 1,000-ton storage tanks. These are linked by pipeline to the mill to feed soaking pits and furnaces. The mill was now almost complete, and the final touches were being added to the site itself, the auxiliaries and much of the finishing line. The first plate was rolled on the 16th of September 1960, just 16 months after the erection of the first main column. By spring 1961, when the official opening ceremony was performed, Hownsgill looked like this, a far cry from the quagmire of 1959. The two main drive motors can together develop a maximum of 31,000 horsepower and can be reversed in under 2 seconds. This is the first twin-drive heavy reversing mill in Great Britain to be powered by mercury arc rectifiers. The Ward-Leonard sets and associated equipment control screw-down gear, manipulators and mill tables. To protect the sensitive equipment from dust, the motor room pressurized. 700 motors are used to operate the roller tables. A separate motor drives each roll. Instruments are placed at key points throughout the mill. These ones at the soaking pits automatically record temperatures and enable optimum working conditions to be maintained. And now, a look at the actual operations. In this stockyard, incoming slabs up to 24 inches thick and of various specifications have been arranged to meet the rolling program. A powerful forklift transports up to 17 tons of slabs at a time. Slabs up to 15 inches thick are taken to the reheat furnace, but larger ones, from 15 to 24 inches thick, are transferred to these soaking pits. Hydraulically operated lifting gear removes the heavy brick-lined doors, and a 25-ton overhead charger is used to handle the slabs. This plant is unique, being the first in the world with oil-electric heating. The system combines the best of both worlds, and at the same time minimizes formation of scale, an important factor in the production of high-quality steel plate supplied by Consett for nuclear reactor shells for British and European power stations. After the appropriate time has elapsed, the reheated slabs are withdrawn for transfer to the rolling mill conveyor. The soaking process is employed only for slabs over 15 inches thick. The bulk of the mill capacity, however, is devoted to thinner slabs, which are subjected to an alternative method of reheating. Slabs under 15 inches thick are reheated in either of two oil-fired reheat furnaces, each of which can handle 100 tons of steel per hour. Controls throughout the mill are grouped in air-conditioned pulpits. This man operates the door gear, pushers and conveyor movements. He is assisted by closed-circuit television, which enables him to see the discharge rolls. Each furnace is 90 feet long and 23 feet wide, a 3-zone design, providing temperatures in excess of 1300 degrees centigrade. Each consumes up to 1,000 gallons of oil per hour. The discharge rolls transport the reheated slabs and those from the soaking pits first to a descaler, where jets of water and chains remove most of the scale. This prepares the slab for rolling. A transfer bogie at present bridges this gap in the roller table, where space is provided for an additional mill stand. The 132-inch 4-high mill rolls slabs to produce finished plates up to 90 feet long and from 3/16 of an inch to 4 inches thick. The roll assembly weighs upwards of 325 tons. Here is a closer view of the rolling process. Rollers nearest the mill have that to right, so that in contra-rotation and turning is necessary to enable the mill operators to control the final plate width. These manipulators not only keep the material centered, but provide indications to the operators of the progressive width of the plate. To ensure the highest accuracy, the rolls are changed after every 2,000 tons of production. The used rolls are reground in the roll grinding shop. Loudspeaker systems ensure close liaison between each operational area. The hot leveler removes any ripples from the plate and imparts a high degree of flatness. The plates are passed to one of two 90-foot cooling banks, and after cooling, dimensions, identification marks, and destinations are marked up on the plates. This is for Consett's new oxygen steel plant. These marks are for the cross-cut shears. Plates up to 40 millimeters thick can be cut to length on the cross-cut shear. A beam of light projected onto the plate ensures accurate positioning, ready for the cut. Separate left and right hand side cut shears are provided to cut the longitudinal edges of the plates. The offcuts pass to a scrap shear, cuts them into easily handled pieces. By repeating the shearing cycle, even the longest plates can be quickly cut to size. A handling gear for the shock blast machine. Shock blasting is optional and is used to remove the thin film of rust and mill scale formed during the rolling process. high-velocity impellers bombard both sides of the plate with steel shot which effectively cleans the surface. Finished steel plates of all sizes and of many different specifications to customers all over the world. This new mill at Hownsgill will double Consett's output of steel plate to 500,000 tons a year. Steel to build ships and boilers, pressure vessels and rolling stock, oil tanks, gas holders, projects. The erection of the new mill at Hownsgill in 2.5 years is the first phase of Consett's £30 million development program and is an achievement of which the company is justly proud.